You can see my screen, right? So the first topic we'll be covering here is SASE easy onboarding. As you are aware, we have unified management and single pane of glass for Prisma SASE through the Strata Cloud Manager, where you can manage both the Prisma Access and Prisma SD-WAN side of your Prisma SASE deployment from a single management console. And we have the integration between Prisma SD-WAN and Prisma Access. We have automated the deployment of Prisma SASE through the use of Cloud Blades for a few years now. With the Cloud Blade, it's a single-click operation where you would go to each site and apply a Prisma Access tag. And at the device level, you would also specify which Prisma Access location you would be connecting that particular SD-WAN site to. So the Cloud-Blade makes things a lot simple, but you have to do it on a per site basis. And you have to also specify the location you want to build the tunnel to from SD-WAN towards a Prisma Access location. So this enhancement we have now makes it a lot more simpler. And we now have native integration between Prisma SD-WAN and Prisma Access. So there is no need for any Cloud-Blade. And the native integration also provides you the benefit of doing automatic detection of the closest Prisma Access location for each of your SD-WAN site. So it will automatically detect which is the closest SD-WAN site Prisma Access location to connect to. You can obviously override it if you want to and make it connect to a particular Prisma Access location that you want to connect to. Another benefit with this native integration is you no longer have to do it on a per site basis. You can onboard multiple SD-WAN sites to Prisma Access at the same time. So for this demo, we have a recording that we will play. So that walks you through the easy onboarding for SASE.
The key benefit of the Prisma SASE solution is the native integration of Prisma SD-WAN and Prisma Access. From our single unified management console, administrators can easily onboard the Prisma SD-WAN branch sites to the closest Prisma Access location with all IPsec configurations completely automated. From the Prisma SD-WAN branch site list, we can bulk onboard hundreds of sites or do it one at a time. You'll see the system will automatically recommend the closest Prisma Access location for each site to connect to, with the ability to override that selection at initial onboarding via a simple dropdown. Select Connect Sites, and the system will automatically create the necessary remote network connections on the Prisma Access side. Additionally, admins have the ability to view and adjust the configuration at the branch site level. Here you'll see the status of the connection from the Chennai branch site to Prisma Access. Customers have the ability to adjust which location and/or which specific IPsec termination node this branch connects to. To assist with this decision, a view of utilization and allocated bandwidth is provided across the entire Prisma Access deployment. Granular controls are also provided to administrators to adjust the routing settings to determine what is or is not advertised to Prisma Access.
Okay, that was a pretty short demo to show you how easy it is to onboard SD-WAN locations to Prisma Access. Again, the benefits are automatic detection of the closest location and bulk onboarding of sites.
The key benefit of the Prisma SASE solution is the native integration.
Sorry about that, guys. I'm trying to move the screen over. Okay, so then second section is enhancing end-to-end segmentation. So we have from the very beginning of Prisma SD-WAN, we have supported network segmentation through the use of network context, where the customer does not have to make any network changes on their side. Instead, the SD-WAN appliance will be providing you segmentation benefits by the use of network context, where you would be assigning certain subnets or VLANs or or interfaces to a particular network context. And the SD-WAN appliance would be providing you isolation and segmentation, and also providing you policies, both path and QoS policies specific to the network context. So you can differentiate both from a policy perspective and isolation perspective. So that has worked well for a lot of customers trying to do segmentation where they don't have to make changes on their side. But we understand that a lot of customer deployments have VRFs. And also there are scenarios where there are overlapping IP addresses across branches, or
Hey,
there are,
Sunil, we
yeah.
can't see your slide. We're only seeing the onboarding video. I just don't want you to get
Oh,
too far into it.
sorry. Thank you, Bill. Let's see can you see the slide now?
We just see the easy onboarding to Prisma Access is all we see.
Okay. Um, okay. Can you see the segmentation side now?
I cannot.
Why is this? Let me stop share and share again. Okay, is that better?
Yes.
Thank you. Okay, so as I was saying, we have the network context capability where you can provide isolation and segmentation and also policy differentiation without making any changes on your existing network. But we also understand that customers have VRF deployments in their network, and they would like to make use of the VRF constructs within the SD-WAN. So that so that purpose, we are now introducing VRF capability in the SD-WAN Prisma SD-WAN deployments, where you can have segmentation. You can define your VRFs on a per interface or sub-interface level at both the branch and data center locations, and we can provide you end-to-end segmentation across between branch to data center or branch to branch traffic. And you can also have policies based on those. So the use cases we support are the VRF segmentation, as I mentioned, across the SD-WAN. We can do both static or BGP routing within a VRF. We can also do route leaking between VRFs, either within the same site or across sites. And your VRF traffic from a branch to a DC or a branch to other branch. And you can also have VRF traffic going directly to the internet with NAT. So with the VRF capability, you can now insert SD-WAN into your existing VRF-based deployments. And this will also now support overlapping IP address space across branches. And will also help in M&A scenarios where where a customer acquires another company and there is overlapping addresses. So by the use of VRF, we can provide the ability to have SD-WAN deployed at both companies. Let's look at how you would do the VRF provisioning and some screenshots to show you. So the workflow, you first define a VRF. So basically you can define VRFs, red, green, blue. There is no need for route descriptors as you're used to legacy networking. It's simply a VRF is a name. And then you define a VRF profile, which has one or more VRFs. So reason for this is, for example, you can have a VRF profile where you define 3 VRFs, let's say red, green, and blue, and you might apply that to 10 of your branch sites. So those 10 branch sites may require those 3 VRFs. Now you can define a second VRF profile, which may have 2 other VRFs, and maybe you might want to assign that to 5 other branch locations, which need to use those VRFs. So this is how you would kind of abstract the VRF application towards your sites. So you define a profile with one or more VRFs, and then you can create route leak rules. So you can say, again, this is optional. If you want to say that I want to import this particular subnet from VRF red to VRF blue, you can define a rule for that, and the system will automatically import, export the routes. Then you would attach the VRF profile to one or more sites. So like I said before, you might have one profile that is applicable to 10 branch sites. You apply that profile to those 10 branch sites. And then at the device level for those sites on the ION appliance, you will assign the VRF to interfaces. So it could be interface, sub-interface. So basically you are defining which interfaces belong to which VRF on your branch ION appliance. And then you can either do static routes within a VRF, or you can do BGP peering within the VRF. So basically, we kind of doing BGP within the VRF for exchanging routes with your upstream or downstream devices. So let's look at this from the provisioning point of view. So when you go to the Strata Cloud Manager, you have the in the Manage section, we have the configure for Prisma SD-WAN, we have configuration profiles. So what is new here is this VRF configuration profiles, which is where we have exposed all the VRF capabilities. You do your VRF definitions. So here you see that there are 10 VRFs defined, VRF 1, 2, 3, 4, and such. It's just a definition of a name. And then you go into the profiles to define the set of VRF profiles. So in the profile, you might have, again, one or more profiles, and each profile can have one or more VRFs. So let's look at that here. So if you see here, when you create a VRF profile, you automatically have the global, which is the default VRF. So this will help in transitioning when your sites do not have VRFs and you upgrade to this new code. All of the existing interfaces will be in the global VRF or the default VRF. And then you can define your additional VRF for segmentation and create the VRF profiles. So in this example, you're seeing that this particular VRF profile, we have selected three VRFs, three customer-defined VRFs, along with the default global VRF. So these belong to the VRF profile we're creating. And then when you go into the route leak rules, you can say that from VRF1, we have a subnet 172.16.1.0/24. We want to export this route or subnet from VRF1 to VRF2. So you simply define which prefixes you want to leak between the VRFs and make sure that this exact subnet exists in the source VRF. And then the system will automatically bring them into the destination VRF. So, and then once you configure that, you save it. So this is the summary page. You see the VRF profile, you see the VRF that are defined within this VRF profile, and any one or more route leak rules that you might have defined for this profile. Then you attach the profile towards the site at the site level configuration. And once you do that, now when you go to the actual device at the site, so let's say this branch ION2 belongs to the site where you have attached the profile to. Now you can actually go and on a per interface basis define which VRF that interface belongs to. So in this example, there is a sub interface that we are assigning to VRF1. And then you can go into a static route. So and in the static route field, you can define a VRF here. So you're saying that this route is within the VRF. And again, the rest of the screen is the same as before. You're simply saying your prefix and the next hop. Only difference is that now we have this VRF definition for the route. Similarly, when you're defining your BGP peering, in the same BGP peer screen as you're used to, you have a new selection for VRF. So you can choose to have this peering within a VRF. So in this case, I'm peering with this peer within this VRF. So this will go through whichever sub-interface is defined in the VRF, and that's where we will do the peering towards the upstream device. And once you have configured it, BGP, you can actually now see what are the prefixes advertised for the BGP peers and which VRF those prefixes belong to. So in this example, we're seeing that there are prefixes within these different VRFs. So that is the end of the VRF segmentation section. I'll hand it off to Bill for the next section.
All right, thanks, Sunil. Appreciate that. Thanks for walking us through those couple of key improvements. Talk about a couple more here we've introduced here in the fall. And the first one being app SLA assurance. So what does this actually mean and where does it fit? So if you think about just the kind of the two base layers of Prisma SD-WAN, you have the elastic network layer, and that's where we have, essentially pools of connectivity, could be 5G, 4G, internet, MPLS, private WAN of any sorts all of that kind of pull together, and then you express your business intent through policy to leverage those different connectivity types. The app-defined fabric is now where we get into the layer of expressing, okay, I have these users using these applications, and they have these expectations out of the network, and building all the necessary connectivity between those different points in the network to facilitate that. We're going to talk through a piece of this that's changing a little bit from prior implementations, where we're taking the SLA configuration from being more configuration driven down at the device level and up leveling that into a policy model and adding a whole bunch more things around it to make it scalable and manageable for you. So app SLAs can key on a few different things, right? With Prisma SD-WAN, kind of a core value prop has always been around understanding the application very well by leveraging our App ID engine, and then capturing multiple different facets of that application traffic. That could include things like, okay, what app ID is it? If it's media traffic, what codec is it? What are the individual transaction times for TCP traffic, and it could be loss for media traffic. In addition to kind of the basic things that you would expect that were more network SLA oriented around jitter, packet loss, and latency. So all those things we analyze and capture, and then we can use those for both visibility and reporting, but also to feed back into path selection. And that's where this new policy model comes into play, where we, of course, identify the application and measure all of its different parameters. Then we've got this new enforcement framework, this enforcement policy. That's where we do app prioritization. We tell the system to find compliant paths and move flows around that are going to be that could be impacted if an SLA might be violated, and then optionally even introduce adaptive forward error correction on the flow to ensure that the lost SLA can be met. Now, all that's well and good, but you also need to know about when those things are happening if it's some of your business critical traffic. So now we're adding the option to be able to introduce an alerting mechanism where if you want to be notified when an SLA is violated, you can receive an incident from that inside of the Prisma SD-WAN console, UI console in Strata Cloud Manager. So as far as examples go, let's talk through a few examples I've built in here in a sample policy. So 4 different rules. There could be any number of rules that you might choose. The rule number 1 is named protect real-time media. And what this one does is it'll, number 1, you define an SLA for real-time media. There is a default for this, by the way, 2% packet loss, 150 milliseconds of latency, and 40 milliseconds of jitter, I believe, are the default metrics. You can, of course, add or change those if you like. I've just created a new rule here that kind of replicates that. And then you say it's only audio and video traffic. So we have a couple different ways to match the application traffic and the app filters. You can do it on like the type of traffic that it is, audio, video, transactional traffic, think web traffic, and bulk traffic, think like SMB or STIPS file shares, things like that. You can match that way, or you can do it on a per application basis, which is the next rule, where we've defined a latency sensitive business applications. Here, we're not worried about correcting the loss as much in this rule. We're more worried about finding a compliant path. So we say the action here is to move flows. And then we've defined certain app filters for this particular customer, which is around their Office 365 suite. So all the Office apps. And then they've got a separate SLA for those applications, which could be, some amount of milliseconds, 200 milliseconds, 2% of loss, 2% or less of loss, and a certain amount of jitter, which is less relevant to those types of applications. Next would be a case where I just want to be notified when my SLA is violated by my carrier. So in this case, I might have and I'll walk through this in a little more detail, but I might have a carrier that has given me a 150 millisecond SLA for latency. And if they violate that, then I want to be notified when that happens. So here I've just configured the action to raise an alarm and to do that on all public circuits under my path filters. And I've given that an SLA. And the same thing for MPLS. I might have a tighter SLA for MPLS And in this case, I want to say my latency should be 100 milliseconds or less. And maybe it's 1% packet loss or less in this case. But I can receive individual notifications on those. Now, in the case that we have an SLA that's violated, you select the generate alarm function in that rule, it will generate an alarm for you to see in the Prisma SD-WAN UI in Strata Cloud Manager. You'll see that that incident pop up. You can drill into the details of that incident and see all the different things that are wrong. In this case, it was a latency violation, of which we're showing latency being violated for this particular circuit. The really cool part is that there's a lot of times you have regional outages, and you'll see this if you ever go to Down Detector. It's this carrier, Comcast or AT&T. They're having a regional outage of some sort or service degradation. In those cases, the Prisma SD-WAN system is proactively monitoring that based upon the SLA that you've defined, and it'll take and let's say it could happen at 50 or 100, or sometimes we have customers with thousands and thousands of locations, so they don't want to receive 1,000 alerts when that happens. What they want is, okay, forget about the noise, give me a single thing to go look at. So in that case, what happens is each branch site will generate its own individual incident that all gets sent to the cloud controller. And the cloud controller in real time says, okay, looks like I've got 100 different sites with this carrier, in this case, AT&T Direct Internet, is violating the SLA of 150 milliseconds of latency. So what the controller does on the fly is says, okay, I'm going to consolidate all these incidents. I'm going to generate a single incident that says, hey, you have a regional problem with this carrier, and here's all the child incidents associated with that. So now you have one thing to go look at, and you go and call that carrier and address that problem with them, versus having to sit through 100 or 1,000 different messages. So it's pretty powerful as far as getting down to that root cause. There's several things in the Prisma SD-WAN that do this same function around getting to the root cause versus showing you all the individual systems. So it's a part of how we build and think about the platform. And this is a continuation of that from an incident generation standpoint and incident correlation. And quickly, just a quick mock-up of showing, hey, I've got a single WAN carrier, AT&T, and then I've got these individual sites that are affected at that on that particular carrier. All right, and then as part of the bigger vision for the Palo Alto network security platform, and that includes things like, of course, next-gen firewall and Prisma Access and ADEM and Prisma SD-WAN, IoT security, and user ID services, and the list goes on and on. There's a lot of things that we do as part of this platform, and we see it as a cohesive platform. So we've been a part of the Palo Alto family now for 3.5 years, and we've made a lot of different like consolidated products that have come together in across the platform. Things that come to mind are ADEM, our autonomous digital experience management agents being embedded into the Prisma SD-WAN operating system going back years ago. So getting that branch level visibility in addition to user and cloud security. That's one example. Another example is how we've done embedded IoT security capabilities into the branch ION as well. So IoT security is really looking at not so much the app or the user, but looking at the device. And is this a trusted device? How it's behaving, and then wrapping, establishing some verdict around the that device on what it actually is, and then delivering that verdict into the platform system. So what Prisma SD-WAN already does, it does two things. One which we introduced earlier this year, where we monitor a couple things in the branch network. So we look for any DHCP traffic either to the ION or through the ION. So we snoop that, and then any ARP information attached to the ION itself. We take that information and we send it to the IoT security service, if you have that service, which then does its thing and crunches all the various parts of that device and what we know about it, and then sends a verdict down to Prisma Access to do enforcement, to either allow that traffic to pass through the network freely or to restrict it, or to block it entirely. So that was kind of phase one, which we did. The new enhancement that we're adding is around SNMP crawling. Because as you can imagine, every branch network is different. And sometimes there's multiple layers of switches, sometimes with a layer 3 boundary that exists beyond the ion. That happens in a lot, depending on your design and your topology. What we wanted to do was get visibility deeper into the network. And to do that, we're leveraging SNMP crawling. So the ion itself can now discover devices using SNMP crawling. And we'll talk through a couple different use cases for that. But the whole intention is to be able to get visibility for those that, we had like probably 95% of the cases covered before. Now we're getting into those last 5% of coverage as far as visibility deep into the network. Now, this is still a Prisma access function. So you'll need Prisma access to do the enforcement for now. And then the IoT security add-on license. Now, we'll kind of walk through the configuration a little bit here. It's pretty simple to configure, really. So you have an IoT discovery profile. And in this profile, you define a few parameters, not many. One, you give it a name. You say, I want to do SNMP discovery and or neighbor discovery. So I can do discovery based upon, like, say, like a LDP, neighborship, things like that. And then once I know that, I can go, if I have the credentials, so we need to supply Prisma SD-WAN with the credentials of the devices. So the SNMP credentials, so it might be your read-only SNMP string in the case of V2. In V3, it's obviously you need the full credential stack to go and do that. Once you configure it with that, then the system, you attach that profile to the branch site that you want to generate this from. And then you give it a source interface. So you want to know where to source the traffic from. And this is actually important for a couple of reasons. And we'll talk about the two use cases next on why this is important. I think there's a couple different ways that we see SNMP controlled in the enterprise network. When I had my network back many years ago, pretty large Fortune 100 network, we went through excruciating pain to control SNMP access. Not only do we have long, complex SNMP strings, we also had SNMP ACLs. So for the use case of where you might only have a few devices that are allowed to talk to your individual switches and routers and wireless access points and all that stuff across the network, we offer a more centralized model where you can configure, one or two devices, give them a list of seed networks, and then they go and crawl all around the network and pull those devices and try and pull in that discovered ARP and MAC table information. That's one way to do it. If it's a little bit more lax and you don't have that restriction, or you maybe limit the restriction to a local subnet, then you can really distribute that service all the way down to the branch. Every branch can do its own SNMP crawling based upon its discovered LDP, CDP neighbors. And then from there, it can get that information and send it up to the IoT security service. So we wanted to offer both mechanisms to be able to facilitate that, again, because there is two different approaches to SNMP access, one tightly ACL controlled and one not. It's just controlled with the credentials, perhaps using SNMP v3 in those cases. Now, once you configure that, as in the previous diagrams, that information gets sent up to the IoT security service. And then that service does all the analysis against all the different logs that are supplied, and it basically forms a verdict on what this thing is. Is it risky? Is it not? And then it distributes that verdict out to the various services that may want to do enforcement against that. And that does include Prisma Access, NGFW, so on and so forth. So again, it's part of this bigger platform where we see security services being ubiquitously applied across all the different edge components, Prisma Access, NGFW, and then also in the future in Prisma SD-WAN as well at some point. That's a possibility. We'll do that. And then for now, we're serving as a sensor, be able to give better intelligence to those enforcement services.